All right, everybody, we're looking right now at the 4-11 notes, and we're going to follow some steps to simplify radicals. Now, you'll notice one thing is that all of these radicals are just square roots. Okay, that's going to be related to what we talk about in our steps. Okay, all of these are just simple square roots, all these examples that we're going to do. And I don't think we're going to do every single one on the page, but I've got a handful of them here ready to go through. Okay, so our first step is to make a prime factor tree for the number. Okay, so on this first problem right here, our number is 48. Okay, 48. This is making a prime factor tree is what you did in probably about fourth or fifth grade. And it's where you would look at that number 48 and you would say, well, 48, I'll just pick some example. That's the same thing as 12 times 4. Okay, and 12 and 4 can both be broken down further, right? 12 is the same thing as 6 times 2, and 6 is 2 times 3. If we go over to that 4, that's the same thing as 2 times 2. Okay, so what we've done right here is we can say that 48 up at the top of the tree up here is the same thing as 2 times 3 times 2 times 2 times 2. Okay, that's the idea here. Okay, so what we're going to look for is after we've made our prime factor tree, we are going to circle the pairs of numbers. Okay, so what I see right here is a couple of 2's that go together. Here, let me see if I can make that show up a little better. What I see is a couple of 2's right there. I see another pair of 2's right there and there. Okay, and since we have those pairs of 2's, we have 2 pairs. That tells us when we simplify this, we're going to put 2 2's on the outside of our radical. Okay, now let's look at the variables. Okay, the variables that are under the radical in our original problem are x squared and y cubed. Okay, think about what those exponents mean. We've got x times x, and we've got y times y times y. Okay, what we're going to do again is we're going to circle the pairs. Okay, just like we did before. We're going to write out all of the however many variables are being multiplied, and then we're going to circle, or in my case, I'm going to highlight the pairs. Okay, we've got a pair of x's, and we've got one pair of y's, and we've got one leftover y. Okay, when we did this with the number, we had a leftover 3 also. Okay, so outside of the parentheses, that's where we're going to put all of however many pairs. Okay, or outside of the radical, excuse me, we're going to put however many pairs. We had 2 pairs of 2's. We had 1 pair of x's. We had 1 pair of y's. Now there's going to be a radical, and we're going to put the leftovers. Our leftovers, we had a 3, and we had 1 single y. Okay, so for my final answer, I'm just going to take all this, I'm going to multiply this together. Okay, most of the time, the stuff that you're simplifying down is just multiplying those numbers because the variables are just kind of stuck where they are. Okay, so for our final answer, we're going to turn that 2 times 2 into a 4. It's going to be 4xy times the square root of 3y. Okay, this right here is the simplified form of that radical that we started with. Okay, what this is saying is that we can take the square roots of all of these items individually and take out the things that are perfect squares and leave the things that aren't inside the radical. Okay, that's basically what we're doing here. Take a look at this next one. This next one I've got is 18x to the 4th, y to the 5th. Okay, so we always start with that number. We'll make a factor tree of 18. First one that comes to my mind is 9 times 2. And we know that 9 is, of course, 3 times 3. Okay, so I look at this, and I go through all those numbers, and I see that we've got a pair of 3's. Okay, so we're going to have we've got 1 pair of 3's, which means outside of the radical, we're going to have a 3. And then let's look at all of those variables. Okay, we've got x to the fourth, which is 4 times, right? X times itself 4 times. Same thing with y to the fifth. Y to the fifth is times itself 5 times. And what we're looking for is pairs. Okay, we're looking for full matching sets. So I've got a pair right here. I've got another pair right there. Okay, we have 2 pairs of x's. So outside of our radical in our answer, we're going to have x times x. I also see a pair of y's and another pair of y's and 1 leftover. So we've got 2 pairs of y's. That'll make it y and y on the outside. On the inside, let's look at what we have left. On the inside of our radical, I see a 2 and a y. All right, so let's take all of those things that we've simplified down and let's break them up. Or not break them up, they're already broken up. Let's put them together. All right, so 3, we've got x times x, which is the same thing as x squared. We've got y times y, which is y squared. Underneath that radical, we've got 2y. What we did right here, what I just boxed in, is equivalent to what we started with. Okay, our next one, 8m to the fourth n to the third. 8 is a pretty quick and easy one. It's 2 times 4. And 4 goes one more time. It's 2 times 2. Okay, so the first thing I notice right there is a pair of 2's with 1 2 left over. Then we've got m to the fourth and n cubed. And we're just looking for the pairs. We've got 2 pairs of m's, 2 sets of m's, 1 set of n's. Okay, so let's get all of those highlighted pairs out in front. Okay, all those highlighted pairs. We've got 1, 2. We've got 2 sets of m's. We've got 1 set of n. And then our leftovers. Okay, the leftovers, we've got 1, 2, and 1 n. All right. So there's that one. Something that I want to point out, and you may or may not have already noticed it, as you're going through all of these problems, you look at your originals, okay? When I look at our original problem up here, what I see is that when I'm taking the square root and the variable has an even power, I'm taking that power, cutting it in half, and that's how many of that variable shows up outside. So on this first problem, we had x squared. That means 1x shows up outside. On this one, we had x to the fourth. We had x to the fourth, and on the outside shows up x squared. On this one we just did, m to the fourth shows up on the outside, m squared. Okay, so that's something to pay attention to right there. The other thing to pay attention to is on these problems, when you have an odd number power on the variable, when you have an odd number, there's always going to be a leftover. Okay, because we're always looking for pairs, right? We're always trying to draw out a pair of those variables, okay, taking the square root of something that's being squared. So that means we've got y squared, okay? We've got y squared times another y. Well, that one that's by itself got left inside of there. Okay, same thing on this one. We took out 2 pairs, and we had 1 left over, okay? So that's a pattern that's going to hold pretty consistently as we move throughout this thing. Take a look at our next one. Okay, our next one, we've got 3 times this square root. Okay, so before we even start, our original problem already has 3 multiplied times the radical. Okay, our final answer is still going to have that 3 as part of it. Okay, so I'll just go ahead and write that down right up front. 3 times whatever else we end up with, it's going to start by multiplying times 3. Okay, so we start with the number, of course, underneath that radical. We're going to start with the number 5. Well, unfortunately for us, 5 is a prime number. Okay, the only way you can multiply and end up with 5 is just 5 times 1, and that's it. Okay, that means there is not anything that we can take out. There are no pairs of numbers that we can take out. Okay, but when we look at our variables, we've got a to the 6th, 6 of those, and b to the 4th. Okay, when we go through, we're always looking for pairs, right? So I see a set right there, set right there, set right there. And the b's, I see a set and a set. So what we're really drawing out right here is 3 sets of a's and 2 sets of b's. Okay, what's left underneath the radical? What's left underneath the radical is everything that didn't have a pair. So there aren't going to be any variables. All of our variables got paired up over here. But what's left underneath the radical is these numbers that didn't get paired up. 5 times 1. Well, if you're multiplying times 1, that doesn't actually change anything, right? Multiplying times 1 does not change the value. So I'm just going to leave underneath the radical, I'm just going to have 5. But I am going to go ahead and simplify all of our variables that we had. We had 3 sets of a's, 2 sets of b's. Okay, so I'm going to simplify all that down, make it 3a cubed b squared times the square root of 5. And that's what we got. All right, we got just a couple more. We're not going to do all the ones that are on your paper, but they would make it a little bit extra practice if you wanted to. Okay, -3, we already know -3 coefficient is still going to be part. We're still going to have to multiply times that when we get to our final answer. Okay, right now I want to use that trick. First of all, we always start with the number that's inside the radical. The question, do we have a number inside the radical? Well, technically, yes. Okay, technically we have an understood coefficient of 1 right in front right there. But that doesn't actually matter because 1 is not a number that factors down. It's just 1 times 1 every single time. Okay, so we're not worried about that. All right, we are not worried about 1. But what we are worried about is all of these variables. We've got u to the 12th power, v to the 4th power. V to the 4th power we can deal with, right? And that's just v times v times v times v is 4 times. I do not want to write out 12 u's, okay? Because that's just going to take a long time, and I don't want to deal with it. So I want to go back to that trick that we talked about, okay? Whenever you have an even number, the amount that you've pulled out is the number of sets, right? What we did is we took that power and we cut it in half, okay? Well, our power on this one is 12, so that means the power on the outside of that square root is going to be u to the 6th. Same thing with the v's. You can actually look at this one. We've got a pair and a pair, so we're pulling out 2 of those, v squared. Now that raises the question, do we have any left over underneath this radical? And the answer is no. Okay, we split both of those since they're both even numbered powers. We split them both into even number. We cut both of those in half and got powers outside of the radical. So we're done. Okay, by taking that square root, we've actually completely eliminated the radical. Okay, I want to take a second and just show you why that is. Okay, think about what we're really doing here with this square root. Okay, this square root is the same thing as if we took the square root of u to the 12th and the square root of v to the 4th. Okay, now as we talked about yesterday, when you have a power and a square root both, what we're really doing is exponent rules, right? What we're really doing is we're taking u to the 12th power and we're raising that to the power of 1/2. Well, when you're raising a power to a power, you multiply those exponents times each other, right? So we ask ourselves, what is 12 times 1/2? Well, it's 6. So this is the same thing as u to the 6th power. And that's how we get this answer out here. That's why we're allowed to just look at, that's why we're allowed to just look at this number and cut it in half, because we're taking the square root, and the square root is raising it to the 1/2 power. That's why we can do this. Same thing for v to the 4th. What we have is v to the 4th power raised to the 1/2 power. So if we multiply 4 times 1/2, that's where we get this answer of v squared. And so that's how this thing out here that we boxed up is equivalent to what we started with. I've got one more. Yes, this is the last problem that we're going to do for this video, and then you'll have plenty of time to work on the homework assignment. Okay, 20a cubed. This time we've got 3 variables going on right here. Okay, so we'll start with our number 20. We've got a, b, and c all involved in this thing. 20, the first one that comes to my mind, could be different for you. The first one that came to me was 10 times 2. And then we've got 2 times 5. To break down 10, 2 and 5 are both prime numbers, so we're done breaking it down. But what I do see is a pair of 2's. Okay, since we have a pair of 2's, then we're going to put a 2 out in front of the radical. Okay, now let's look at all these variables. A cubed. Okay, that's an odd number, so we know we're going to have one left on the inside. Okay, it's a times a times a. We've got a cubed, that's one pair that gets taken out. If we've got b to the 4th, we've got 2 pairs right there, right? We've got 2 pairs right there. So that'll be b squared out in front. And if we've got c squared, that's one pair, right? That just by itself, that is one pair. So we'll pull out one c out in front of it. Our radical, let's look at what we have left. Okay, our leftovers, I'm looking at a, one single a, and one single 5. So on the inside of there, we just put 5a. And there we've got it. All right. Take a little time and work on your assignment right now. That is all we've got. That's all I'm going to look at for the notes. I know there were more problems on your paper. Those can be extra practice for you. Okay. As we're looking at it right now, that's all we've got. So y'all have a good one and have a good day.